Okay, so in this video I'm going to talk about sysfs, udev, and dbus. So sysfs is an in-memory file system that the kernel uses to provide information about the system to user space applications like udev. It was created as the procfs file system was not structured or designed for this task and was becoming cluttered. The sysfs file system can be accessed from the /sys directory and contains directories and files that can be accessed via the shell. The information stored in the sysfs file system is in plain text files and can be read by programs or system administrators. The sysfs file system was added in the 2.5 kernel. Now, for those of you that don't know, the 2.5 kernel was the development kernel, a testing kernel, so it wasn't used in the real world until the 2.6, but it was added in 2.5. Alright, so understanding udev. So udev replaces the dbus file system, which was used in the 2.4 kernel. dbus was used to dynamically create device nodes in the /dev directory, but relied on kernel modules for naming device nodes. udev was introduced in the 2.6 kernel and gives the system administrator more control by allowing the use of udev rules. So udev rules allows the system admin to rename the device files and load custom kernel modules and things like that if necessary. So udev creates dynamic device nodes in /dev directory and will also remove device nodes from /dev directory when devices are removed from the system. udev runs in user space and can change device nodes using udev rules. udev was added in the 2.6 kernel and relies on the sysfs file system. So the sysfs file system was added in the 2.5 kernel. sysfs makes devices visible in user space. The kernel will produce an event notifying udev when devices are added or removed from the system. So when devices are added or removed from the system, the kernel sends data to the netlink socket. The netlink socket is how the kernel communicates with user space programs. The udev daemon listens to the netlink socket and will act on the data received. So prior to the udev and devfs, Linux used to have static device nodes in the dev directory, making it difficult to know what devices were actually in the system, and it was lots and lots of files in there and a really big mess. So that's why devfs and then udev were created. So udev rules are located in the /etc /udev /rules.d directory, and there's udev adm is a user space utility for working with udev. So now we're going to go into understanding dbus. So dbus is an IPC, inter-process communication mechanism that helps applications communicate with each other and is developed as part of the free desktop projects. So dbus has a daemon that runs on startup and it mainly listens for hardware-related events. dbus has a session daemon that is started when the user logs into the graphical environment and is used for desktop applications to communicate with each other. So dbus is used to notify desktop applications of hardware-related events like a USB storage device being plugged in, and can pop up applications asking how to handle it. So if you put in USB stick, it may pop up a file browser. Or if you pop in like an SD card with photos in it from a camera, it may ask whether you want to bring up a photo browsing software, or a file browser. If you put a CD into the system, it may ask you if you want to load up a music playing application, so stuff like that. So any of the hardware related pop-ups is handled by dbus. But dbus is also used to notify other programs what they are doing. For example, a music player could let other applications know what song is playing. So email could also let other applications know when email is received. So it's used for both hardware-related events and also events happening in other pieces of software. So in the next video, I will actually go in and show you some stuff on the command line.